Okay, so here is the logarithms unit review. We're going to start off with this problem over here. We have log base x plus 3 of 2x plus 3 plus log base x plus 3 of x plus 5 equals 2. First things first, we want to use the product rule to condense. So we condense the logarithms, and we end up with 2x plus 3 times x plus 5, right? Now, we go around the world, x plus 3 squared equals 2x plus 3 times x plus 5. If you choose to FOIL first before you go around the world, that's fine. So we rewrite in exponential form. So we have x plus 3 squared equals 2x plus 3 times x plus 5, and x plus 3 squared gives us x squared plus 6x plus 9 equals 2x squared plus 13x plus 15, right? FOIL this, get this, FOIL this, get this. Now we want to combine like terms, subtracting from one side to the other. And we subtract from the left side to the right side because we want our x squared to be positive. We want 0 to be on one of the sides so we can solve the quadratic. So we subtract, and we end up with 0 equals x squared plus 7x plus 6. We factor. X plus 6 times x plus 1 equals 0. And our solution set is -6, -1. Now before you just say that's the answer and be done with it, you need to plug back in for the check step. So we'll plug in -6, and we end up with 2 times -6 plus 3. We end up with -12 plus 3, which is -9. Remember, you cannot take the logarithm of a negative number, so we have to reject -6. Now if we take -1 and plug it back in, 2 times -1 is -2 plus 3 is +1, and -1 plus 5 is 4, so we are taking the log of both positive numbers, so that's why -1 is acceptable, -6 is extraneous, -1 is the only solution. Jeff has $10,000 to invest for 3 years. Compare the worth of his investment if he chose the 6% compounded monthly account with the amount he would have if he deposited the money in the 8% compounded semi-annually account. So we're looking at scenario 1. We'll call this scenario 1. We'll call this scenario 2. So we want to calculate the principal of $10,000 for both scenarios. N is the number of times a year that the money will be compounded, the interest will compound. So we have monthly, which is n equals 12. Semi-annually, which is n equals 2. The interest rate is 6%, so we have to change it to a decimal, 0.06. And the interest rate here is 8%, which is 0.08. P is the time, which is 3 years for both situations. So when we plug this all into the calculator, very carefully into the formula, then into the calculator, we end up with $11,966.81. And for scenario 2, we end up with $12,653.19. So clearly, scenario 2 is the better deal. It will actually yield $686.38 more than the other account. Which equation can be used to find continuously compounded interest? B. A equals P e to the RT. I call it per plus equation. Imagine continuously pouring out shampoo, continuously compounded interest. So we have $50 to invest at 7.5% interest for 10 years. Principal is $50, rate is 0.05, and T is 10. The amount of money is questionable. We don't know what it's going to be, so we must plug it into PE to the RT because it is being compounded continuously. 50 times E to the 0.075 times 10 is $105.85. In the diagram below, figure B is the reflection of y equals 2 to the x power in the line y equals x. So this figure here is the reflection of this graph. Remember, when we reflect over the line y equals x, it is the inverse. And remember, the inverse of the exponential function is the logarithmic function. So we can solve algebraically. And since we know that this is a logarithmic function, we can cancel 1 and 2 because neither of these have logs. When you solve algebraically, you swap the x's and the y's. So the y becomes x and the x becomes a y. We solve for y, which means we'll have to take the log base 2 of both sides. This cancels out, and we're left with log base 2 of x equals y, which is answer choice 3. This is pretty straightforward. We want to rewrite the base as a common base. We rewrite it as 2 squared. We distribute the 2. We cancel out the like bases. And we set the exponents equal to each other. Add 6 to both sides. Divide by 2. Factor. And our solution set is -3, -1. Both of these check out. And as you can see, there's a check step. So they're both acceptable answers. Here we have a properties of logarithms question. Here we are condensing. First thing I do is the power property, log x squared minus log y cubed plus log z. Then I apply the product property. I change the addition to multiplication. And then finally the quotient property, which condenses everything to x squared over y cubed z, the log of that. Here we are going to expand log of xy to the 1/2 power in parentheses over z. Then we apply the quotient property, the power property, and then the product property. Remember that this stays in parentheses because originally it was in parentheses because xy is under the radical. When you're dealing with the half-life question and they don't give you the original amount or the amount, the half the amount, you make up your own numbers. So I chose to use the original amount as 1, and the amount you're left with is half of 1, which is 0.5. So we plug 1 in for a sub o, and we plug in 0.5 for a. And we basically solve for t. We divide both sides by 1. The opposite of e is ln, so we take the ln of both sides. We end up with the ln and the e canceling out. Divide both sides by -0.021, and the answer is 33.01 years. The equation for the radioactive decay is P equals 0.5 to the T over H power, where P is part of the substance with half-life H, remaining radioactive after a period of time T. A given substance has a half-life of 6,000 years. After T years, 1/5 of the original sample remains radioactive. Find T to the nearest 1,000 years. Okay, so H is 6,000, T is what we're looking for, and P is 1/5, which can be rewritten as 0.2. Right? Because it says 1/5 of the original sample, so 0.2. We take the log of both sides. As you can see, T over 6,000 comes down as the coefficient. I multiplied both sides by 6,000. So it would cancel with this. And then I divided both sides by log 0.5. This is so we can isolate T. Now that we have the T by itself, we need to carefully evaluate this expression. And as you can see, putting this in the calculator, parentheses, 6,000 log 0.2, close parentheses, divided by log 0.5, and our answer is 13,931. But since they wanted t to the nearest 1,000 years, 14,000 years is the most correct answer. And there you have it. I hope you are ready for the logarithms test. Best of luck to you.